All right, we're going to go ahead and get started. Welcome everyone to our sixth talk in the School of Teacher Education Colloquium series. Today's talk is by Dr. Sherry Southerland, who's a professor in the Science Education Department. The title of her talk is Learning by Collaborative Design, Professional Development. Dr. Sherry Southerland is the Anne and John Davis Professor in the Science Education Program and co-director of FSU Teach, a secondary STEM teacher preparation program at Florida State University. She's a fellow of the American Association for the Advancement of Science, a fellow of the Royal Society of Biology, the leading professional body for biologists in the United Kingdom. And she's the co-editor-in-chief of Science Education, a preeminent international journal in science education. She has been a biology teacher in multiple contexts, as well as working as a field biologist and a forensic chemist. Dr. Sutherland's research agenda involves the study of the development of students' science sense making, the examination of ambitious science teaching practices, and teacher moves that best the learning of traditionally underserved students, and the examination of factors that influence teacher learnings. So Dr. Sutherland is going to talk for 30 to 35 minutes, or close to 40 minutes. And we will leave the Q&A until after the talk.
Thanks so much for coming, everybody, and thanks for the invitation. This is great fun once you make the PowerPoint. So I'll be talking about learning through collaborative design, professional development. Let's see. This is a project. It's actually turning into a 5-year project funded by the National Science Foundation. Thank you for your tax dollars. And it occurred to me, of course, after I put the talk together, that it's important, I think, for the academics or the faculty in here to realize that this grant is the result of 5 grant applications, twice to the IES, where we were triaged, like meaning nobody read it. And then 2 or 3 times at the NSF. So grants aren't, they're never like this single run thing, but they take a lot of work to get to the point where you're allowed to do the work. So hopefully that will become apparent as I go through the talk. So before I get into learning through collaborative design, I think it's important to highlight the team members, because this project is really, the strength of it comes from its team. Remember, we were turned down a lot. And then we hired 2 awesome new colleagues, Lama Jaber and Marai Tukumurkisa, and they brought with them new ideas, new ways of looking at things that allowed for the project to really come into its own, to begin to say something that somebody else would care about. Lama brought her work on teacher learning and the affect related to that. Mirai brought her vast work in terms of the use of videos and work products as site for teacher learning. So they really help bump the project up to the next level. Other project team members include Ellen Granger and Todd Beavis, who've been just instrumental, like essential in this work. They are from the Office of Science Teaching Activity and Outreach. Todd and Ellen brought a long history of doing effective and rigorous professional development for STEM teachers throughout the Southeast. And the last PI, and so yes, all of these are co-PIs. The last co-PI is Patrick Inderly. He is a former graduate student, but more importantly, he is now an associate professor of science education at Georgia State. Patrick was brought on the board because he's had a long history in designing curricula that foster argumentation, and he knows the work involved in supporting teachers and trying to implement that. So that's why Patrick was brought on the team. But perhaps the most important of everyone that I will talk about today is our project manager, and the research faculty, Dr. Jennifer Schellinger. She's the one that makes all of this possible. She keeps us all busy. She keeps us assigned to task, all of us, PIs, co-PIs, all of us. And she's really sort of the cognitive network of the group. We have 6 graduate researchers currently working on the project: Ozlem Okan, Ryan Coker, Harini Krishna, Sierra Morandi, Asli Kaya. All of those work in the School of Teacher Education, and they're been helpful in both collecting and organizing data, which is a vast undertaking and really thankless, but as well as coming up with ideas about research projects that could be important. And we also are working with Claudia Hagen, who's a graduate student at Georgia State. We've had a number of undergraduate researchers that have worked with us. Excuse me. And graduate student wise, Danielle Reamer, Sam Scrobe Martin, Dion Wilson, and Victor Casper are graduate students that have worked with us in the past. So let's see. So today what we're going to do is I'm going to orient you to the goals of science education. I wish we were all in person so I could see from your face if what I'm making makes sense, or if you've already heard it so we could know how to pop through, but you're just going to have to suffer through it, because learning by collaborative design, that project doesn't make sense unless you understand the goals that we now have for science learning in the 21st century. So we'll orient to the goals of science education. I'll give you an overview of the program, and then we're going to talk about what we plan to do and what we were allowed to do in COVID, not allowed, what was possible to do in COVID. And then what that taught us about teachers' lived experiences as they've taught over the last 2 or 3 years. And if we have time, I'll give you a snippet of some research that has spun off from this work. By the way, I've set my phone so that I don't talk us all into oblivion. So the goals of science education, you probably heard Mirai, Lama, Amel, graduate students point to this, but what we're hoping for students in the 21st century is very different than what we hoped for from the past in terms of what we want in terms of science learning. Today, science learning is really conceptualized as a 3-dimensional process where kids are asked to use the big ideas from the disciplinary core ideas, the patterns of thinking that you typically see in science, as well as scientific practices such as investigation and argumentation, all together to try to make sense of some aspect of our world. So within this paradigm of learning, really, science learning is seen as the development of proficiency in science. We're not so much worried about what they can do in a worksheet. We're worried about how they can construct a robust explanation for some phenomena. Within this idea, students are thought to learn science or develop proficiency by doing science, thus engaging in the practices of the discipline. Students learn by working to figure out their world. So that's something that's heavily privileged in our community. Now, back when I was a high school teacher, and this pains me to say, that was in the last century. Last century, when I was a high school teacher, this was the picture of what we thought a scientist looked like. Yes, it is a white dude. He is in a coat. He is working with a microscope all by himself. This is what we're thinking is going on in science. Today's portrait of scientist and science learning is a much more collaborative endeavor. It's discursively rich as kids work together to not only come up with ideas, but refine ideas. So our portrait of what it means, what it even looks like to learn science is very different than what it once was. I think this is encapsulated really well by Brian Reiser's idea of the 3 spheres of scientific activity. Again, last century, back when I was a high school teacher, we really worried about investigation. Like, we wanted our students to do labs where they pursued typically some cookbook set of directions, but they had their hands on something. So they were doing an investigation, and then they would then use the results of that investigation to develop an explanation or just to answer a question. So investigating and developing explanations, those 2 spheres have always been with us in terms of science teaching, or have been since the time of Dewey, about 100 years ago. But what is really interesting about the current set of national reform efforts is this evaluating sphere. So Brian and others have brought to the fore the role of argumentation, critique, analysis. It's not enough to come up with an idea as a scientist, like that lone person in the earlier picture. you have to like check your ideas, not just against nature, but also against your colleagues' ideas. Like, so there's this constant issue of critique and analysis, argumentation, and we see this is just as important as the other spheres. And to boot, this somewhat new sphere, or a new sphere to science teachers, is a discursively rich activity. So talk features heavily in this evaluation sphere. So an example of an instructional model that uses that, all three of those spheres is a claim, evidence, reasoning. If we were all together, I'd tell you to raise your hand if you've ever heard of this. It is a instructional model that is seen in many parts of the country. It's not, I don't know if we can call it prevalent, but it's not anomalous either. So it's beginning to have some uptake. In the claims, evidence, reasoning model, you're asking students to create an explanation. Sometimes people call that an argument. And that explanation includes the claim, like an answer to a question, then the evidence on which that claim is made, and then the reasoning, the scientific ideas that tie the evidence to the claim. All three of those together are important. Again, in my past science life as a science teacher, I probably would have really focused on the claim and maybe given a little attention to the evidence, but not so much reasoning. Today's approach to science teaching, what we expect of learners, is to construct an explanation. An answer to a claim always must be accompanied by the appropriate evidence and with an understanding of how that evidence is linked to a claim. Here's an example of what some of these explanations or arguments would look like. Notice they're on whiteboards. If you've ever been in G106, you probably see a lot of whiteboards. It's not that we just like find them cool, but these are like artifacts of instruction. So what would happen is a group would conduct an investigation, and together they would collaborate in creating their explanation on a board. Here we can see we have a claim, they provide the evidence, and then give a justification that ties the three together. And by putting it on a whiteboard, then it becomes this public image in which other students come around, look at the board, begin to ideally ask questions about how did you collect that evidence? What did your data look like? Why is your claim different than mine? So we begin to see that explanations are being critiqued, evaluated, and revised. And it's that process of talking that we see is so inherently important to support student science learning. Another instructional model that bounces off the same idea is argument-driven inquiry. Some of you probably have heard this. It's an instructional model that was developed here at FSU and at TCC. It was directed by Vic Sampson. Ellen Granger and I worked with him on that, and as well as Patrick Inderley was one of his research assistants. And it is another instructional model that supports students in the construction of arguments. Not just the construction, however, the revision and critique of those as tools to support the development of student science proficiency. Here's an example of some kids engaged in argumentation activities as well as example boards, and teachers become really comfortable with these boards once they get as tools, once they get used to it. And another whole talk could be who benefits from this form of instruction. We have a lot of data to suggest that traditionally lower performing students do very well with argumentation-based activities, or activities that position them as knowledge makers. So disciplinary engagement in science, this notion of three-dimensional learning, requires 3 dimensions, as we've talked about before, and all of those are used in the service of sense making about some aspect of our world. And those are discursively rich activities. It requires students have a certain willingness to navigate uncertainty. I think humans are pretty good at that. We teach students to not value uncertainty through much of their early education, and sometimes in their later education. But so we have to kind of reawaken that willingness to engage with uncertainty. And requires students to embrace some aspects of epistemic affect, that notion of excitement, frustration, vexation. All of those are part and parcel of doing science. And we've got to teach students or help them develop an appetite for those sorts of epistemic affect events. Now, teaching through students' disciplinary engagement requires teachers to see value in students' everyday ways of reasoning, requires that teachers recognize students as active epistemic agents. That is, they don't just consume knowledge, they produce knowledge and they work together to refine it. They need to become aware of the role of student talk in that knowledge production and refinement process. They need to recognize and learn to support the emotional components of students' work, as well as teachers need to develop proficiency in the use of curricular materials that support students' efforts. Teaching through students' disciplinary engagement is very different than what typically happens in most science classrooms. Again, I'm not going to say it doesn't happen, but it is atypical. Unfortunately, it requires significant changes on the part of most science teachers. This is not how many of us learned science ourselves, and we probably didn't learn to teach in this way in our own education. These changes moving toward this epistemically and discursively rich classrooms require not just new tools and curricula. ADI did that, CER did that, whiteboards, we've got tools, but we need an effective means of professional development to support teacher learning to use those tools. Tools aren't enough. You've got to have a well-prepared teacher. And that's the focus of this project, is what are the changes required to support teacher learning around this. So enter learning through collaborative design, professional development. And the intent of this project was to design an approach to professional development to best support teachers as they learn to engage their student in productive talk in their classroom. So learning through collaborative design, professional development, it's posited on the notion that teacher collaboration around the redesign of curriculum and its enactment and analysis allows for teacher learning. And it does that by improving teachers' ownership of their materials. It increases their engagement in thinking through the materials in ways that allow them to better support their students, and it fosters the development of social networks that are useful in sharing and providing guidance on the particularities of science lessons. So the structure of LCD-PD is twofold. So this first circle, and all these graphics, any graphics that you see ever associated with me come from Dr. Jennifer Schellinger. This first graphic indicates that the first piece of LCD-PD involves 6 full days in the summer in which groups of teachers are put in the position of learners so that they learn to engage with discursively rich materials where they're positioned as science sense makers. And then we back away and try to figure out how that event was structured. And then how could they go and revise curricula that would allow them to do that in their own classroom. We do that for 6 days. And then following those 6 days, we engage those teachers in 4 rounds of in-school cycles of collaborative design. They're design, teach, analyze cycles. So we get together, typically in the afternoons, because they didn't want to get substitutes, even back in the day when substitutes were available. So we would meet after school, redesign materials. And when I talk about redesign, it's not like we're building new things. I call it futzing. They're just making this curriculum fit with their students. They're revising it so it will be useful for their group of learners. So they design the materials together, then they go out and teach it, typically individually. Our team is there to capture video of those teaching events. And then we get together as an in-school cycle team to pick out snippets of those videos and snippets of work products that will allow us to reflect as a group on how things went. And based on those analysis sections or sessions, then teachers go back to their curriculum and revise them for the next year. And we do that 4 different times during the academic year. So learning through collaborative design actually has 2 research foci. One includes sort of the longitudinal development of teachers as they engage in these cycles. And that's what this slide is about. And the second one has to do with the field testing of the materials. In the longitudinal studies, we started in year 1 at a local district that won't be mentioned, with just 19 teachers, and then 4 of them allowed us to follow them. And then in year 2, we took our show on the road, the revised professional development. We did it with another district in mid-state, in which we worked with 13 teachers over the summer, and 5 allowed us to follow them. And years 3 and 4, we've just continued to follow a subset of those teachers. Now, the field study is the second component, and this is what I think NSF is the most interested in. Ideally, what we had planned to do is to have a field study where we compare 3 different groups. One is the learning through collaborative design, where teachers are engaged in materials as learners, and then they together collaborate on their revision. We were comparing that to a very similar approach to professional development, but it's much more traditional, in which teachers are just led through the materials, again, in the position of learners, but there isn't time set aside for them to rework those materials collaboratively. So the only thing that's different really between the 2 groups is the focus on collaboration and revision. And then we were going to compare the success of those 2 treatments to a control treatment, which was to be drawn from teachers in those same schools. You'll notice my tenses are getting really weird here, because what we plan to do and what we could do were different things. So in the field studies, we were collecting classroom observations and recordings from everyone. We planned this to have teachers collect their own data by providing them recording equipment. That didn't work out so well, particularly now that we have masks and we're a project that is focusing on student talk. I hope you can see the contradictions there. So we've done classroom recordings and observations. And again, this is why our research team has been so good, because it's meant that some of us had to go south and spend time in Airbnbs while they're collecting data from schools. We did a host of teacher surveys as well as student assessments. So we were looking to see the effects pre and post on students who engaged in different forms of talk, as well as interviews with teachers. So those are our different forms of data. Now we have a number of current research projects underway. Many of them focus on something very different than the role of collaboration, and some, yes, we'll just leave it there. So there's 3 dissertations. Harini, Özlem, and Danielle are all working on dissertations or preparing to work on dissertations using data from the project. We've had a recent publication. Dr. Schellinger has been the lead on that, in which we developed and produced psychrometrics for a 3-tiered instrument that allows us to understand both what a student knows and what they can do with that knowledge. And then we've had roughly 40 conference presentations and proposals over the span of the project, including 6 from undergraduates. So here is our original research plan. So year 1, we're working with a district and we're just trying out the PD that we've designed. Based on what we've learned, we were planning to go to year 2 to another district where we were going to try out that PD that we've designed, and then continue to follow up with the teachers from year 1. In year 3, we were going to go to a 3rd district. So we have the ultimate version of the learning through collaborative design, professional development, where we were going to also compare it to learning through participation and control while we were following up District 1 and 2s. And year 4 was going to be this lovely year where we sat back, drank cappuccinos and analyzed and wrote. It was a fabulous world we were living in. This is what happened. So in year 1, we didn't get nearly as many teachers, and even fewer teachers were willing to sign on for the cycles, in-school cycles, even if we had substitute money, even if we paid them to come after work. It was over and beyond what they were willing to do. Year 2, we had fewer teachers, but we continued to follow up with individuals from year 1. COVID hit the United States at the end of year 2. So we rapidly transitioned to year 3 being a day for analysis and writing. So if you were impressed, which I hope you were, by the 40 presentations and 40 different research projects, it's because we had year 3. We're all on salary because graduate students don't evaporate when your field sites close. So we put that time to use. Year 4, we went to our 3rd district. We thought as COVID was waning, this was before we knew of variants, like we were beginning to put away our masks. And that school district gave us the green light. They're like, yeah, we can do this. We want some PD. So we had a lovely summer in year 3, in which we got to work with only 16 teachers. That's all we could really convince to participate. And 8 of them allowed us to continue on with in-school cycles. But then the variants hit, and schools became very different places. So it was impossible for us to convince any teachers to come on with us in controls. I like to highlight the teachers that worked with us in the summer and that stayed through the cycles of collaborative design. They're staying with us. They're finding something of real value here. It's just the teachers for whom we had no personal interactions. They didn't see the benefits beyond a paycheck of doing this. The control teachers just, we couldn't convince anybody. But we continue to follow up with student teachers from District 1 and 2. And we're hoping, we haven't written our no-cost extension yet. We're hoping year 5 will be that lovely year of cappuccinos and writing and thought. To be determined. But this change has required us to reconceptualize how we're going to approach the data. We were originally going to do a quasi-experimental, quantitative, multi-level comparison of the impact of these 2 different models, or excuse me, 3 different treatments. That has shifted to comparative case studies across 2 treatments. So that's really put a premium on those observation data that might not have been originally. But what has this taught us about teachers? So as teachers decide not to continue with us, or if they are expressing any tension, so I'm in the process of conducting interviews with them now, and they've taught me a lot. High school teachers, these are high school biology teachers largely in South Florida, have lost planning periods. They're teaching routinely 2 and 3 extra classes that they may not have ever prepped for. Many of them are helping long-term substitutes who have no science background with planning. So they're trying to help their long-term colleagues. That's eating up all their time after school. Some of them have collapsed classes so that they're teaching 60 to 70 students in lectures. That's unheard of, but this is what's happened as we have teacher absences of routine teacher absences of 25% or more, and navigating students' absences of up to 30%. So how do you do these discursively rich activities when students may or may not be there? And then how do you catch up the ones that aren't? These are all questions that our teachers are struggling with. And as importantly, particularly for this project, many of the students who are in this project this year were middle and maybe the first year of high school during online instruction. So they haven't really been in a high school before, and they don't know how, they're not socialized for high school yet. And they've been able to turn off their video screen and just not participate if things got too hard, or if the questions were too difficult for them, or they could go and Google something really quickly. You have these same students in classrooms now that are trying to do that in real time. Like they just won't talk, thinking that somehow they won't be noticed. So teachers are really struggling with getting those students back into the swing of things, and some of them for the first time. But our teachers that have worked with us have been grateful for an opportunity to think deeply about a lesson with a colleague. We do a lot of doom and gloom about teachers, but the teachers that we're working with, and that's many, and I think they're similar to many teachers around the country, they want to be professionals. They want to think deeply about their practice. And so when you give them the opportunity, it's going to be 3 hours or more. They're eager to share insights they've gained from teaching a lesson with others. So there's none of this competition of it's mine, I'm doing this. They want their colleagues to succeed. They want other students to succeed. And they remain really grateful for the way these instructional materials allow their students to engage deeply in sense making and learn to talk in ways that are productive for creating knowledge. And they've been really happy to see that these instructional approaches often can support the learning of students who traditionally underperform in science. So study exemplar. And so this is the last bit, so don't worry. And I'm just going to give you a snippet of an EERA presentation that we gave last year. And it included Jen, Sierra, Lama, Mirai Takumurkisa, as well as Harini. So the focus of this work is on the ripple effects of epistemological framing, how a teacher's move shapes students' framing of science. Notice this isn't necessarily about collaboration. It's just one of the spin-offs that's possible once those data exist in the world. So our research focus with this effort is to examine one teacher's effort to engage in reform-based instruction, that is the argumentation, talk-rich teaching. And we looked at this teacher's effort through the lens of epistemological framing to trace how the teacher's moves influenced how the students understood their efforts. So our theoretical lens is epistemological framing. And for those of you that don't work in this area, framing is the expectation that an individual has about a situation that influences what they notice and how they act. So there's going to be two frames that we invoke in this work, doing school and doing science. Doing school frame is thought to be invoked anytime we're positioning students just as receivers of knowledge. A doing science frame is invoked anytime students are positioned as sense makers. So the methods we used, we gathered these data through the from the first year of the LCD PD effort, and we followed Jerry. He was one of the teachers that allowed us to continue in his classroom. Our data sources include classroom video observations of 3 different tasks: characteristics of life, cancer, sexual selection. We conducted student interviews, both open-ended and stimulated recall, and we looked at teacher and student work projects. For the purposes of this snippet, we're just going to look at the cancer task. Let's go back. The cancer test, if it helps you to know, is an application text. So this is a task that you would ask students to engage with after they already knew about cell division and they sort of knew what it looked like, but it's an opportunity for them to take that knowledge to try to understand something or to try to explain something. So it's called an application task. It probably would be one of the things you would do in the latter part of a unit. So for data analysis, we looked at our videotapes and characterized them at for different sections because we saw different activities happening across the 4 sections of a lesson. The first one is the potential, like what is the potential of the task to allow for particular kinds of thinking? How is the students' work launched? Like how were they started in this work? We looked at their small group efforts as well as the wrap up. We identified instructional moves on the teacher's part in each phase, and then we analyzed student small group work and interviews to identify themes. So the two frames that we'll use in our analysis, again, is doing school. That's anytime you're emphasizing completeness. You have prescriptive instructions where you go from 1 to 10 instruction and you have to follow them all, what we used to call a cookbook lab, where you're highlighting correct content over everything else. Anytime a teacher takes over a student's thinking intellectually, we're calling that a doing school frame. A doing science frames emphasizes figuring things out. It invokes students' conceptual resources. When students' work is deeply considered for ideas and thoughts, when you're pressing students for explanations, we're calling that a doing science frame. So here's our task. Our guiding question was, which of these patients could have cancer? And what the students were asked to do is to look at these 4 different pictures of cell slides. So slides of cells from 4 different patients. 2 come from the stomach, 2 come from the pancreas. And based on what they know about cellular division and how that should look, they need to decide which of these could have cancer. So it's a very open-ended task. And so we're suggesting that the students' efforts here is framed in doing science. Like, here's the information, try to figure it out, try to develop an explanation. As this teacher, Jerry, launches us, he says, we're going to be assisting doctors. So as he's saying we're going to be assisting doctors, he's really positioning students as sense makers. Then he follows with some pretty prescriptive instructions. First part you're going to read is basically a brief summary of what we talked about yesterday. Then the bottom part is going to describe your task for the day. So he's really telling them what to read to get started. Then he follows with, I'm not going to tell you how many of the 4 have cancer. That answer or that statement suggests I know the answer and I'm waiting for you to tell me what's right. So those are very much framing the students' efforts as doing school. So we see the launch as both emphasizing figuring things out as well as prescriptive instructions. So as we get into the small group work, we begin to see students as sense makers, and they are really beginning to get into a productive struggle. Alexis says, do you see how the cells are starting to fade out? That could be a breaking of the barriers of the tissue. Throughout the whole picture, there are cells. If you look at it, it means it's not undergoing mitosis, which means it's cancerous. But there are this many cells dividing at the same time. That doesn't make sense. So they're really wrestling with what they're seeing there. Like, they're asking questions that are open-ended. They're really framing their efforts in terms of doing science. And so Jerry comes to this group, or comes to a similar group, and he says, there's no wrong claim if it's supported by what you guys talk about. So he's saying, like, your board is right as long as your evidence is consistent with your claim. But then he continues, there's no wrong claim for your poster. So again, positioning students' efforts as doing science. But then he continues, but for your final write-up, there isn't a right answer until the final write-up, and then there's a right answer. So he's positioning or really emphasizing correct content with that move. So in the small groups, we see both evidence of framing for doing science, but also framing for doing school. As we go to the wrap up, Jerry takes over, and he sort of consolidates what he thinks is important for this. He's not calling on the students, he's telling them what he thinks is important. So he calls up the slides and he says, patient 2 is a healthy patient. Some of the things you see here are the cells that are pretty spaced regularly, lining the tissues of the stomach. So he's telling them the answer and telling them what accounts for that answer. And then, even though they're dark, patient 1 was said to have cancerous cells, and the focus was on the top left of this image. So again, he's telling them what the right answer is and what the evidence for that answer is. So we see here as an emphasis on correct answers and the teacher's intellectual takeover of the work. So as he's wrapping them up, he says, first and foremost, I know it says on the paper, their task. to write your group's claim, but don't write your group's claim. You're writing about the accurate claim. Patient 1 and 4 have cancer, so your evidence should support the claim. So he's telling them what to write and then emphasizing that their evidence needs to support that. So he's really taking over their work. That means we need to hush. So what are we going to do with that? I think it's just important as I wrap up, like the launch only took 14 minutes. The small group work was 89 minutes. And that wrap up, that really teacher heavy wrap up is 7 minutes. So it's just a snippet of time. But if you look at what the students are saying, the kids understood that like their work in the launch was to try to get other points of view. In the small group, they were trying to learn how to interpret different ways to interpret evidence. Like they're trying to learn from one another, as all in the effort of trying to explain why something happens in nature. So they're framing their efforts. But when you ask them about the wrap up and ask them about overall the lesson, they consistently said, in the end, he did tell us what like the main reason is. He'll show us what the correct answer is. So kids know if they wait him out, he's going to tell them what to think, which is sort of the antithesis of doing science. So with this, we see one teacher's moves, how it shifts the framing of what could be really robust learning events and really turns them into much more prescriptive events. And that's why teacher professional development is so essential. It's not the tools, it's what the teachers do with the tools. And with that, I will hush. Yeah, there we go. I have time for questions. So Jennifer.
Jenny, I was going to say, I see Jenny Todd's hand up there. Go ahead.
Hi, I'm so sorry that I missed part of your presentation. We had a fire drill over here at the psych building.
Oh, no.
So I'm not sure like if everything was covered, but I was wondering, since you can kind of you're looking at this framing and you're noticing where teacher practices could improve, what might be your next step to help teachers reflect on their own practices to kind of support these different framings?
So that's a really good point, because framing dynamics wasn't one of the foci of the in-school cycles, but sharing those data with the teachers. So looking at data, not only from themselves, but from their colleagues seemed to be really important, and to see the big impact of small moves. And I know with his own teachers, and Lama can, or Jen, any one of the team can jump in, it did point to us, you know, more fundamentally, Jerry has this notion of there's wrong and right in the world, that it's not so much that science is producing a useful explanation, which is probably what I would say. He would say it's identifying a big truth in the world. And that, I think, would be worth exploring a bit. But I think he's very interested in getting, he's a wonderful teacher, but he's very interested in getting his kids these sorts of experiences. So I think just by highlighting what those last sort of moves could do has been influential. And after this point, Jerry worked collaboratively with a more experienced teacher, and he learned so much from watching her videotapes.
You know, this is Lama. Thank you, Sherry, for the presentation. Thank you, Jennifer, for the question. It's making me wonder too, and I don't think we've used that as a resource, but your question is making me wonder, like, how can we also draw on students' interviews? There are tricky things there, because, you know, we need their permission and there's power dynamics, but could those be maybe after the fact, after the year has ended, to use those as part of the reflective experience for these teachers. Like, so those become data they can engage with as they reflect back on some of their actions. So how are teachers picking up on their moves? Sorry, how are students picking up on the teacher's moves? How are students kind of orienting to these 7 minutes as very consequential for how they frame their effort throughout? And might that kind of destabilize the teacher's attention to correctness in that wrap up, or help the teacher realize, oh, I can kind of message the wrap up a little bit differently?
And eventually, Jerry learned from his colleague, Kate, the power of using the students' work in that wrap up. You know, like not just, I call it not just the cookbook approach of like taking your pre-cooked notion out of the oven at the end of a cooking show, but rather like bring the students' ideas to the fore and use those to build ideas moving forward. He began to see the power in that by watching his teachers, but we were very careful. You know, so much of this is emotionally difficult, not to overload teachers with what might be perceived as negative messages. And I think in the future, trying to share much more explicitly about like, what are your students saying could be helpful, particularly if we get to work with them multiple years. So those students are no longer in their classrooms.
I wanted to add that,
Oops.
oh, sorry, I just wanted to add that we're seeing that in our subsequent years when we're collecting data, that a lot of teachers don't, when we're in the classroom and we're making observations and collecting video data, that last little bit of wrap up, which often happens, you know, the following day, they don't see it as part of the lesson. And that tends to be when they are giving these correct answers. So we're starting to see that in our larger sample of teachers. And we are attending to that now in the professional development during the school year, sort of attending to those wrap-ups and the impact of those wrap-ups.
Yeah, and also like another thing to add, so this is Mirai, by the way. So thanks for that question, Jennifer, because like one thing that we tried is to really use the video records from teachers' classrooms to really have this reflection on their teaching or their colleagues' teaching, so that they can kind of like notice some of these moves that they are doing. That might be really productive or not, sometimes not really productive for their students' intellectual engagement. And actually there was like an aha moment, I think in one of either the third or the fourth session, where we were analyzing some clips from both Jerry's classroom and also the another teacher who was a little bit more experienced, but he interacted more as they were collaboratively designing some lessons. So we kind of purposefully selected videos from both of their wrap-ups that were very different, but that clearly showed him being more active, basically transferring the information to students. And at the end of that discussion, we heard from him saying like, oh, actually, like when I'm looking, comparing the ways in which that I was engaging with students' ideas in that wrap up in comparison to this other thing that I'm seeing in other colleagues' classroom, I think I just need to just like wait a little bit more or think about like different ways to engage students in that wrap up. And then he kind of like revisited that idea several times, saying that like that is something that he is actually working on. So it basically like became an awareness for the teacher that that is something that he is doing, that he's now noticing, that he needs to act on more, especially in cases where he wants to give more voice to students and he wants students to do that that sense making with their peers in the classroom.
Sherry, there is a question in the chat regarding your framework and your choice of framework for your study. If you would like, I could read it, or if you have it right there.
Could you share a little bit about the choice of framework for the work? Was there a moment you considered another framework to analyze the data? Jen, my memory is not good in the best of times.
I don't know how I don't think we did. I think this is hate to say it that way, but this is sort of a framework that we've used to view other sort of similar ways of doing in science classrooms that really align with the sort of ambitious instruction that Sherry talked at the beginning. Go
It's
ahead,
a
sorry.
framework Jen used in her dissertation. So
yeah.
it was one that it was a tool ready to hand. Now I remember, yes.
And it does a really good job of sort of acknowledging these ways that we want students to engage in classes and how the teachers really set up these activities for this work.
But that's a great question about like how things get done. And in this case, Jen had done a very nice job of using this framework for a chapter in her dissertation. So we were, that was like foremost in our mind because the focus there too was on the impact of teachers' moves. And so it imported nicely here.
And actually we did just look at teachers' moves to begin with. We were just looking at it through a lens of teachers' moves, and it seemed to help us understand those moves a bit more by adding that lens.
Well, and not just the teachers' moves, like the students' responses. We get really excited about these videos when kids are arguing, like trying to figure out which ones might have cancer. That's just big science stuff. So we get really excited, and that excitement then transmits into wanting to include those data. So framing is a way that you can capture the impact of the moves on students.
Thank you.
It's good to see you.
I have a follow-up question from my previous one. So it feels like a lot of deep learning for like the students and the teachers happens through this feedback and this kind of cognitive dissonance of like what I'm doing, what I'm seeing. And it just feels very individualized. What are your like big plans kind of for this model in the future? Do you see it as like a model that other people can use when working with professional development?
Well, our real answer, Jennifer, is we want to see the importance of designing and collaborating as opposed to just deeply engaged in the material itself. Like both sets of teachers that we're working with have deeply engaged in the lessons, but one group of them, we've set aside time for them to collaborate and to refine. The other ones, we're just saying, go teach these things. So we're hoping to see, but it will now be through case studies, the impact of that collaboration, because, as professional developers, it's hard to get time together and you don't want to waste it. If that collaborative redesign process doesn't buy us anything, let's not use our time. We can get through more lessons so they have more comfort. If their comfort with a lesson overrides anything they might learn from collaboration, let's not spend our time that way. So that's the ultimate take home, like how useful is collaboration, collaborating to learn to foster student talk.
Thank you.
I just want to add though that the original plan, you saw those numbers originally, we plan to have many more teachers during those in-school cycles that happen during the school year. And so with those smaller numbers, it sort of just lends itself to those teachers maybe being more personalized. So we're finding that again, as our numbers have sort of dwindled during this field study year, that it just sort of lends itself to maybe more personal interactions that if we had more teachers, our original plan maybe would have lended itself to.
But Jen, like both sets of teachers, the learning through participation and learning through collaboration, the same phenomena exists. Like there's a small group that get together and talk, 4 times a year. So, but to be frank, the collection of video data, and Mirai can speak to this better than anybody, like that is this labor intensive process. We're finding that it's really important to think about who you're going to feature, not just for like what techniques you're featuring, but everybody wants to see themselves. You don't want to just focus on one teacher. You don't want to position one teacher as in terms of negative feedback. Like there's this emotional component that needs to be taken care of. that's going to be hard to scale up because it takes a cast of thousands to get the data, the observations, and go from that to like 3 or 4 snippets that you're going to use to support student or teacher thinking. That's hard. That's hard work. Yeah, Mirai's like shaking her head. Yeah. You told us it was going to be hard. You were right.
I had a question, Sherry.
Yes, ma'am.
So this resistance to change, to go from this correctness is what you call it, right? How much of it would you attribute to the teacher's beliefs, I guess, or what would you say?
Wow, we need a glass of wine for that one. That's a big question. Because we live in the state of Florida, where we think that truth resides in facts. So how much of it is teachers' fundamental epistemological beliefs and how much of it is supported by the context? I don't know how we can tease that apart. I think Jen's earlier question does highlight something. When teachers see other teachers pull off something lovely, where students are in the driver's seat, they are impressed and they want to begin to do that. So when they begin to see what's possible, then it ups their game. And so it's not like, you're going to change their epistemology and change their practice. Those two things go together. By changing their practice, you might be shifting their beliefs. But the context we're in still heavily privileges like uniform facts.
Thank you.
You can tell it's Friday.
Any final questions or comments for Dr. Southerland? We have 3 minutes.
I would share, Dr. Southerland, I really appreciated at the beginning how you acknowledged that the grant was not funded and that it is a very, collaborative process, and how engaged your graduate students and undergraduate students were. So I appreciated and valued the whole presentation, but I know that part is going to stick with me because it's something that I can directly apply.
That's great. I do warn you about the evils of an overly large team, though. It's virtually impossible to get us all together at one time. Just can't be. So just while it's wonderful, it comes at a cost.
Well, if there aren't any final questions or comments, I guess we'll go ahead and wrap. And thank you, Dr. Southerland, for your time, and everyone else. Stay tuned for information for our March Colloquium series. Dr. Rob Schoen will be presenting, so we'll be circulating that information in the next week or two. Hope everyone has a lovely weekend. Thank you.
Thanks for coming.